Warm-ups. Number 1, a Ferris wheel has a radius of 8 meters. It goes around once every 4 seconds. Find the frequency. So this 8 we need to recognize as being equal to the variable r. Goes around once every 4 seconds. So that is the period. The variable for that is the capital T. We want to find the frequency. So that is going to be the little f. So we're looking for an equation with little f in it, and we only have one actually to choose from. Little f is equal to 1 over capital T. So we better hope that we know everything else in this equation besides little f, and we do. So I can put in my number for the capital T. We get 1/4, which would be just fine as an answer. Or we can turn it into a decimal and make it 0.25 hertz. Number two. It's the same kind of a thing, only now we're looking for the tangential velocity. We still have a radius, r, of 8. We still have a period, capital T, of 4 seconds. But we are now looking for a v. So we need an equation with v in it. We have 2 to choose from. We have capital F equals m of v squared over r, and we have v is equal to 2 pi r divided by capital T. Both of those are in our list of equations. They both have the desired v in them. So we got to see which one's going to work. In this problem here, we want to find the v. We better know the numbers for m, r, and f, or at least be able to get them. I do not know the f. I do not know the m. There's no way for us to get those, so we cannot use this. This is bad. Scribble it out. So let's look at this one. Let's see here. V is equal to 2 pi. The r is 8. And the capital T is a 4. Typing that into the calculator, 2 times pi times 8 divided by 4 is 12.56. This is a velocity, so meters per second would be the appropriate unit. Number three. A 50-kilogram child. That sounds to me like a mass. It's at the edge of a merry-go-round. The ride has a radius of 2 meters, so that's the variable r. It goes around once every 2 seconds. That's the period, capital T. What is the force? We're looking for a capital F. What is the force needed to keep the child from sliding off the ride? So an equation with capital F in it. Well, for this unit, we only have one. F is equal to m of v squared all over r. We have had other equations with capital F, like F equals ma. We could use that in this situation if we were given the acceleration, but we're not. Okay, so putting in the numbers, the m is 50. The v squared, we're not given a v squared, are we? So we better be able to find it, otherwise we can't use this equation. We thankfully have a way of figuring that out. We could do off to the side, v equals 2 pi r over t. This is the circumference of the circle. This is the time to make one circle. So distance divided by time. Okay, so the v is 2 pi, the radius is 2, and the time period is 2. So the velocity is going to be 6.28 meters per second. I can put that in for the v squared. And then divide by the radius, which is also 2. Typing that out, 50 times 6.28 squared divided by 2 equals 985. Let me type that again just to make sure. 50 times 6.28 squared divided by 2, 985. And the unit for forces is a Newton.